Hey guys, and welcome back to the Wake Up Call 101 channel. So today we are talking about the buffer solution and shifting away from the chemical kinetics topic a bit, taking a break from it. Now we are doing the buffer solution, which is under the aqueous equilibria. Okay, so you may have seen this term before, or you may have used this solution before in your experiment, and you wondered why, or you wondered why you were using this buffer solution, or maybe you didn't hear as much. But we use this buffer solution to maintain the pH of that solution that you're working with. So that is why you add the buffer solution. So the buffer solution resists drastic changes in pH. So when a strong acid is added in small amounts, or a strong base is added in small amounts, it will not affect the pH of your solution because you have a buffer solution. You added a buffer solution in your solution. So the buffer solution consists of acids and bases with which are highly concentrated, so that it will, like, when you add your strong acids to your solution and your strong bases in small amounts, it will not affect the pH of your solution. And the buffer solution is composed of two parts: the acidic component and the basic component. The acidic component is to neutralize your OH minus that you add on your solution, and your basic component neutralizes your H plus ions added to your solution. So to make a buffer, you need a weak acid and its weak a weak acid and its salt, or a weak base and its salt. For instance, if we want to use a weak acid, acetone, famous example, you will use its salt, which can be CH3COONA, sodium acetate. So for acetone, we use its salt called sodium acetate. Okay, so also have weak acid base conjugate pairs. So I'm gonna write a typical example of a buffer solution, like a reaction. I don't know what to call it, but like, let's prepare a buffer solution. Okay, let me just say that preparations of a buffer solution. Typical example is when you have your weak acid. Let me just use the acidic. Let me just use the weak acid for now. So you're gonna use your weak acid is HA in aqueous solution, forming H plus ions in aqueous solution plus A minus ions in aqueous solution. So guys, I hope you understand the principle behind the weak acid base conjugate pairs. Okay, so we have our weak acid here with this conjugate base here. So this is our weak acid with its conjugate base. Because they differ in the proton, so it has one proton here, and then here it does not have that one proton. So yeah, that is why we say this is the conjugate base of this weak acid. So this is our buffer here. Okay, this is our buffer solution. So in your experiment, you add OH minus, which is a strong base, in small amounts, will decrease. Okay, no, remember I said the OH minus will be neutralized by the acidic part of the buffer. So this is the buffer, right? So it will be neutralized by the acidic part of the buffer, which is this weak acid. So it will react with this weak acid. Okay, let me just pause the video. Okay? There's a lot of noise outside. Okay, so when you add small amounts of OH minus to your solution, it will react with the acidic component of the buffer. This is the buffer, right? So it will react with a weak acid, which is HA, forming H2O and more of A minus, our conjugate base. Okay. Okay, so this reaction here is the one that's occurring when you add small amounts of the base. So it will react with the acidic part of the buffer. So this means it decreases the concentration of the weak acid, but in small amounts, because remember the buffer is made up of high concentrations of both the acids and the bases, so that the pH will not change. The pH of your solution will not change. So it does little effect on this. It decreases a bit, like in small amounts, and making more of H minus. It's just a little bit of addition of the conjugate base. So that's what happens when you add small amounts of OH minus of your strong base into your solution that you're working with, which consists of a buffer. So what if you add a strong base, a strong acid? If you add a strong acid, it will, because it's a reaction, because it's a strong acid, it will react with the basic component of the buffer, which is the basic component of this buffer here. It is this conjugate base. So it will react with this A minus here, forming HA, which means it forms more of the weak acid. So this means that when you add your strong acid, a small amount of your strong acid, it will decrease the amount of the conjugate base, increasing the amount of the weak acid, but in very small amounts, because remember the buffer solution consists of high concentrations of both acids and bases. So it does a little change. The addition of your strong acids or bases does very little change in your solutions. If you have your buffer in there. Okay, I hope you guys get the gist of things. Buffer solution is made up of a weak acid and its salt, or a weak base and its salt, and when you add a strong base in small amounts in your solution, it gets neutralized by the acid on the acidic component of the buffer solution. And if you adding your strong acid in small amounts, it will be neutralized in your basic component of your buffer. So this is the typical buffer that I made here. So this is the acidic parts that I'm talking about, and this is the basic part that I'm talking about when I'm using my weak acid. Sometimes you can use your weak bases. You can get your weak base here and your conjugate acid here, okay? And your weak base will have your conjugate acid would have an extra H, an extra proton, okay? Because it is a conjugate acid after all. So thank you guys for watching my video. Hope you enjoyed, and stay tuned for a whole lot more. Thank you.